Here's our drone in its natural environment. As you can see, it is made out of the frame and two motors. There are two thrust indicators on top of the motors, the red bar indicating the current thrust and the gray bar indicating the maximum possible thrust. When these thrusts are just right, the drone can hover, but if they are mismatched, it can lose control and fall out of the sky. There are also wind in the environment which can affect the drone, and the goal of the drone is to land in the landing zone area shown by the box below at the bottom of the screen. Here is our drone flying untrained. You can see it flying off to the side, flying crashing to the ground, losing control, flying off the top. All things that a drone should not do. Now, we can compare and contrast what you just saw there with a trained drone using the PPO model for 250,000 training step. As you can see, the drone, despite initially being at a very tilted angle, it can very rapidly gain control of itself and rapidly descend initially before slowing down to make a safe landing. Now let's try adding uncertainty to this mix. Here now you can see the effect of low center uncertainty on the drone. As you can see, the drone still can approach the landing spot with great speed, much like before, but it is now much more uncertain when it gets close to the ground, as it is unsure of the landing zone and when it's crashed. And indeed, we can see that often it does not land in the landing zone and instead land outside of it, where it still gets a reward if it does not crash, however, much less than if it were landing in the landing zone. If we crank the sensor uncertainty up to high, which is around 5% of observation, you can see now that the training is completely ruined. The drone does not even try to land as it cannot be sure that it can land safely. On the other hand of the uncertainty, actuator uncertainty seemed to have a less of an effect. Here showing the low actuator uncertainty, which is 0.5% of the range, can see that it is still capable of landing within the landing zone relatively safely most of the time. However, once the actuator uncertainty gets high, the agent also seems to be no longer willing to land and instead tries hovering above the ground. Now let's look at the combination of both high sensor uncertainty and high actuator uncertainty. As you can see, the drone is no longer even capable of hovering in place. Instead, it drops rapidly before stumbling around and sometimes even drifting off the screen. And now on to the effect of the environment on the drone agent. Now for constant wind, which is simply a constant force applied on a drone in a certain direction, doing both training and testing, we can see that it does not affect the drone agent that much, and it can still safely land most of the time. Now, in random wind environment, however, we can see that it does seem to have more of an effect. The drone still attempts to land rapidly on the ground, and sometimes it succeeds even in landing in the landing zone. However, it is no longer as consistent as it was previously. It sometimes even drifts off the screen at times. So that's the end of our video. Thank you very much for listening, and hopefully you found it interesting.